I hope I'm live now. Okay. Let me quickly verify if my sound is audible on the stream. And in this stream, we are basically just going to, I will basically show you how to set up Qwen 2.5 14 billion instruct model on your laptop locally, and also how to set up stable diffusion and a bunch of other models locally on your laptop. So if you want to make something like a clone of ChatGPT yourself that can run locally, and you don't want to worry about being dependent on OpenAI or sending data to some Chinese company like DeepSeek, then welcome to the stream. I'll start in a bit. Let me just first verify if the sound, yeah, the sound is fine, everything looks good. I'm gonna start now directly. I'm just directly going to jump into the code and show you how things how you can do things. So for the text LLM, we are going to be using Qwen 2.5 14 billion instruct model. This is one of the recent models that was released by Qwen, which is I think which is managed by Alibaba. So Alibaba released the group of models called Qwen. You have like a lot of models here. You can go to Hugging Face, and you can also try and chat with Qwen in case you want to do that. And I just got to know today that in just a few hours, Qwen would be making an announcement, I guess, where they are going to be releasing some other stuff tonight. So keep an eye on that if you're interested. With that being said, Qwen released a bunch of different models. They have the 72 billion parameters instruct model, which is like the biggest model. I won't suggest you to use this model on your laptop, especially if you don't have like a good GPU or whatever. I don't. I mean, so in that case, I would stick to using a 14 billion parameter model. And also, I feel for general tasks, this is more than enough. Again, I would like to emphasize on one thing, which is that Qwen 2.5 14 billion model, this is what I'm choosing to use, and the reason is that my laptop doesn't have GPU, so I'm gonna have to stick to CPU. And when you really want to use some powerful LLM on your local machine, you should do this thing called let me show you this thing called quantization. Quantization basically is the technique used to reduce the size of the model by converting the weights and activation from floating point to lower precision numbers. So basically, you can the weights and biases of the model, they are floating point number. You can convert them into simple integers so that you can run those calculations on your CPU and still get response in a good time. So you can do a bunch of, there are like bunch of different ways of doing quantization. You can download like 2-bit, 4-bit, 5-bit, 6-bit, 8-bit quantized model, and I don't know what else, 16-bit probably. So there's like different models here that you can directly download using this button, and then you can keep these downloaded models in a separate folder, and then you will have to write some inference script to load these models and then use them. The way I did that is probably the easiest and probably not the best way, but I just chose to do it because it was super fast. So what I did basically, I'm gonna go to cursor and show you. I downloaded the models here in this folder Qwen. These are my 3 files that I downloaded, 1 2 3. Each file is around 3 GB, so a total of 9 GBs of model weights, and I downloaded them from here like this. So I chose the 3 files that were named 1 2 3 of the main 2.5 14 billion instruct model Q5. Q5 is the 5-bit quantization, I guess. I'm not fully sure, but yeah, Q5 is 5-bit quantization. This is like a decent like this falls exactly where I want it to be. It's fast, but it's also accurate enough for most of the use cases. So I chose to download this. Now what you do is that you download these, and then you use something called Llama inference module, which is provided by Meta. They have Llama inference module. You can download Ollama. Ollama is like a software that you can use to interact with the local models that you have downloaded, and these models could be Qwen. You can use Llama, or there are a bunch of other models. You can choose any of these models and directly use llama, llama, which kind of provides you a GUI that you can interact with. I did not choose llama because my aim here is to sort of create my own interface, and interface that is very similar to ChatGPT. For example, as you can see, if you go to the ollama page, you'll find that ollama you can use llama 3.3, DeepSeek R1, 5.4, Mistral, Gemna, and other models locally. So you just download this and you can then pass in your weights, the path to your model weights and biases, and then ollama will take care of everything else, and it will just work like a ChatGPT in environment. You can also download models from here, which is also a way to do that. So there is the option to download Qwen 2.5. You can just go here and you can download these models. And you can choose the different versions of that. The 14 billion one that I'm using, it is total of 9 GBs, which is exactly how which is exactly the size of these 3 files that I downloaded. So once you have downloaded these models, there's other thing that you can do, and what I did was basically I went to Cursor and I asked it to I downloaded llama cpp, and then I asked Cursor to sort of help me create an API for this. But if you have downloaded llama cpp, you can run that directly here. The command is llama CLI. This is the llama CLI. You have to make by the way, you have to make this. So in order to make this, I'm going to show you what I did. I went here, I did like a whole conversation with ChatGPT trying to understand what model would be good enough for my laptop, and I told it that I'm using Mac M2 Pro Max, what size should I stick to, and how to quantize the model, and how do I download that, how do I run that. I asked a bunch of questions. It told me that you're supposed to use llama platform. So the steps were very simple. You can ask this. I'll show you the prompt. The prompt was, what is the download size and how do I run that? ChatGPT told me that you can use the llama cpp. Go to that thing and just build it. Once you have built it, you'll get a bunch of script in the build folder here. So inside of the build and bin, you'll see you have a bunch of different scripts. One of them that I'm super interested in is llama CLI. If you run this script, you'll basically run the model on the CLI, and there is another one called llama server. If you run this, you basically run a server, say on port 8000, and then you can send a request to that server, and the response would be the model response. So you get all these different scripts that you can use. We're gonna just stick to llama CLI script, and when I do that, you can also provide like an initial prompt to the script. I did that, and then the model would be loaded on my local machine. It is currently being loaded on my CPU, and once that is done, I can start talking to the model. I can be like, okay, how many letters in the word strawberry? Letters in the word strawberry. The word strawberry has 10 letters. How many R's in the word strawberry? The letter R appears twice, which is incorrect, but I can ask that question again, hoping it will get the answer correct. And I intentionally asked this question, by the way, because most of the large language models get this question wrong. Even ChatGPT would be getting this question wrong 2 or 3 months ago, until they released the reasoning version of that. But that's okay. So this is the llama 14 billion model running locally on my laptop, and it doesn't always give you the wrong inputs. Just to confirm that this is good enough for most of the use cases, and the reason why I'm saying that is because I have asked it a question, intentionally a question that most of the models do get wrong most of the times. Do you want to test this? Let's test this. How many R's in the word strawberry? Let's see how the response would be if we go to, let's go to Gemini. Probably Gemini. I hope Gemini gets it right. Okay, right now we'll try Copilot. Copilot must get it right, because ChatGPT did make some updates which now like their thinking mode, that helps you give the correct answer. There are 3. Okay, Gemini 2.0 Flash gives the correct answer. That is cool. Let's try some other model. It'll be very funny if only Qwen gets it wrong. but we can go to the Qwen chat Qwen dot AI. Let's ask it here. Sometimes it gives correct, sometimes it gets it wrong. See, this time it was correct. Let's see if I can make the model give the correct response. Think and reason very hard before you answer. How many words? The letter, oh no, why don't you go one letter each, now one letter one by one, why don't you go through the letters one by one and tell me how many R do you find in the word strawberry? Oh, it did not respond me anything. That's funny. I found 2 R's in the word strawberry. That's very funny. Anyways, so a lot of models do get this question wrong a lot of times, but that's okay. The point is that now I have a local large language model running on my laptop, and it might not be as good as the current state of the art models, but it's good enough for most of the cases. Okay. Let's try one more use case, because I don't feel good with the fact that it is getting a very easy question wrong, which to be fair is not the easiest question. You can just go here and do some research on why do AI models fail to answer how many letter R's in the word strawberry, and you'll realize that this is like a very common problem. See, why can't AI count the number of R's in the word strawberry? And until last year we have had this problem in pretty much all the models, but now we don't do that because we have the reasoning models and they are really good. But with that being said, it's okay. Do you want me to try another example? Let us try another example. Give me HTML code with Tailwind and CSS inside of it for a simple website that has a button saying hello world in the center of the screen. This is a very tough task. I'm asking AI to center a button. It's a very tough task. Oh, by the way, you'll probably have to do some other stuff also. This is a good example for you if you want to know how to set these models up locally. This is a good example because what's happening here is that you realize that the model response was cut off, and that is because this script llama CLI, this script just processes the response of the model until it hits this ending character. And since while generating HTML we hit the ending character twice, it just ended the script right there. The script just stopped. So these are some of the limitations if you want to use the llama CPP directly, and that's why I'm going to show you what I was trying to do now is that instead of sticking to llama CPP, I am asking it to create a simple Python server. So this is what I did. I asked Cursor to help me create a Python script to run this in the chat mode, and you can do that too. Of course, there's like a Python library that you can use, load the model directly, and then start a chat loop. And this works way better than the CLI script that we just showed you, because it has some of its like cons, so be aware of that. Enough about the LLM. Let's talk about the image creation, the text to image thingy. The reason why I'm talking about text to image now is because in normal ChatGPT we have both the text generation as well as the image generation, and that's why if you want to create a ChatGPT kind of an app locally, you will need to figure out how to generate the images also. And to do that, this time I completely stuck to Cursor and I did not use anything else. So first I went to I created a new project in Cursor, and the prompt was Can you tell me if there is some open source text to image model that I can download and run locally? It gave me a bunch of different options. After doing my research on those options, I decided that I want to stick to Stable Diffusion. So I asked it to set up Stable Diffusion. The way it did that is very simple. You go to this repository, the Stable Diffusion web UI, which is sort of a UI, web UI, where you can provide the Stable Diffusion model, and this UI will basically, you can interact with it, you can write the prompt, you can hit the generate button, and the model will be used to generate the image. So that was very cool. To download the model, you again go to Hugging Face and you type in Stable Diffusion v1.5, v15, and then you can download the model just like you downloaded Qwen. So you download it from here. I already did that, and I put the model in the correct place, which was the models and then Stable Diffusion, and this is where I put the model. I downloaded two different models. I downloaded a Realistic Vision v51 as well as a Stable Diffusion 1.5 because I wanted to see which one is better. I kind of realized that Realistic Vision is much better, especially if you want to create images that look realistic, as the name suggests. So I stuck to using this model. Now this is where I did something different. I did not want to use this web UI again because at the end of the day, I just want to create like APIs for myself so that I can use those APIs into my own personal app that I will be making. So to create the API, what I did was this time I again used cursor, and this time my idea was different. My idea was basically that I would ask cursor to use the code in the Stable Diffusion web UI repository and tell me how we are using the model inference. So it did tell me a bunch of other stuff, and after reading through that stuff, I was like, okay, I instructed it to create like a separate module. I call it the inference module. I can push that to GitHub if you want. In fact, I'll do that because that sounds like a good idea. What I'll do here is that I'll create like a git ignore first, git ignore, and let me put .env star dot or just Gemini chat.py output. Output is fine, and I wanna make sure that I don't push the models, so let's just put that in the git ignore before pushing this thing on GitHub, because if you don't have cursor, you can directly just use my inference module to interact with the model, which is also possible now. So you can just go to, where was I, model, Stable Diffusion, and then this. So I'll just do dot save tensors and a bunch of other stuff in case any of that is important. So I'll push this after this stream probably, and this inference module I created after going through this code, and now in this inference module things are pretty simple because we have this example.py where I show you how to use this. It's very simple. You just pass in the prompt to this example.py, and then that example.py will take the model path, whichever model you want to use, and then it will load the model using the loader class, which is also created and saved here. So this is the Stable Diffusion loader class. So you just use this class. I can push all of this code. By the way, you can get most of it here on this repo, but I'll push you the other code also. So you take this and then you simply load the model, pass the prompt, and save the output image to whatever directory you want to. So this is how you set up like Stable Diffusion locally without having the web UI. And yeah, by using these two things, you can now you have like a LLM that responds to text responses, and then you also have like a text to image model. So when you combine both of them, you can create your own local chat GPT. I'll work on this off stream later on, and then whenever I'm done working on all the weird quirks that you just saw, things like the model was cutting off the response, and there are other stuff also like like the inference right now. I don't want to use llama. I want to use some custom things. So once I'm done figuring out all the quirks related to this, I will make a video and show you how it looks when you have like a local chat GPT. So yeah, with that being said, this is pretty much all I wanted to share in this stream. It was a quick stream. I did that because somebody asked me to show how to do all of the things that I talked about in my previous video. So this video is specifically for you. I hope it is helpful for anybody who's looking to just explore these open source models. And yeah, I'm gonna stream again probably towards the end of this week because I have a bunch of different projects going on. So till then,